All right, so we give this a go. This is a pretty typical question in some ways. Differentiate, hence integrate something. So it shouldn't be too difficult, but there are some twists and turns, which is why I've been asked this question. I think it's quite long when you actually end up solving it, especially if you do it all properly. Okay? Yeah. Why don't you borrow from someone right now, and then go get it in 5 minutes when I'm done. Writing paper. Borrow from someone. Okay. Part A we can all do. So you tell me what to write. What am I going to put down first? Come on, guys. You could have done this months ago. Where am I going to start? Okay, so it's a quotient, right? So I'm going to go, this is my U and this is my V. Okay, so let's just rehearse quotient rule. Okay, V. Oh, no, sorry. This isn't integration. U dash. Yes? Yes. Okay, good. Minus U V dash. So far, so good? Yes. Right? Okay. On what?
1 plus x squared all squared.
Okay, good. We're still awake. Okay.
Yes. Yes.
What's on the bottom? Sorry, what's on the top?
1 plus x squared minus 2x squared, so it's 1 minus
Which is?
1 minus x squared.
Yes.
Okay, so I'm done. There's not much else you can do to that. Not much else that will help anyway. Okay. All right, now part B. Here's where the fun begins. Now, before I actually start, usually you'd write this down, okay? But it's a hence, so we're building on what we got from this part here, okay, from part A. So this is the result that I established, that the derivative of that function, oops, is equal to this. Okay, so what would you suggest would be our next step? What should I write down? Remembering this is what I'm trying to work out. Right? What should I do? Okay, I could do some substitution, right? Why would you though? Why would you? Keeping in mind that we know. The whole point of establishing this, right, is so that you can establish a primitive function for this, which isn't a standard one. Okay, if I'd given you this and say, okay, integrate from there, it's sort of, that's not a normal function I'd expect you to recognize. Okay, so now I've established that this, all right, yeah, this is the primitive of this. Okay, so how am I going to use that fact for this question? Okay, I should integrate, right? Now, I'm not just going to integrate anything, yeah? I'm going to integrate on a certain boundary because the question is on a certain boundary, right? Okay, let's do the right-hand side first. I'll just write that down. You integrate this from 0 to 1 with respect to x, so nothing too dramatic. Okay, now what will I write on the left-hand side? Remembering that this is a definite integral. I've integrated the right-hand side with respect to x from 0 to 1. When I integrate this with respect to x from 0 to 1, what am I going to get? I'm going to get square brackets, right? Because this is the primitive, but I want to evaluate it from certain boundaries. Okay, if I don't evaluate it, if I just do the indefinite integral, what difference would it make? I'd have, you lose these boundaries, you lose the 0 and the 1 in square brackets, you have x on 1 plus x squared plus the constant integration, okay? But since it's a definite integral, I don't have to worry about the constant. Okay. Right, now what? Okay, so what I've got here, right, let's just make that minus sign a bit clearer. This I've written as one fraction, okay, but because I've got two terms on the top, I can just break that apart into two fractions, yeah? Okay, but before I do that, I think that's going to cause me some problems, right? It's going to cause me some problems. Because, have a look at it. What I want over here is the 1 on 1 plus x squared all squared. That's okay. That's the part that I'm after, okay? But, let me show you. Yeah, take that. Thank you. But, have a look at what you're going to have on the bottom, okay? Now I'm just going to write this off on a separate color so you can see the issue that I'm trying to draw your attention to, okay? This integral, I'm going to break it into this one, 1 on 1 plus x squared squared, There's the first part. Okay. No, I haven't finished the integral yet. Okay. So I've got, there we go. And then I've got this, x squared on 1 plus x squared squared. Okay, now before I go any further, okay, I want you to stare at this for a little while, okay? This guy, I don't know what it is, but that's kind of the point. That's the question, okay? So I'll leave him for now. Now have a look at this. What is this? What integral is this? What's the primitive going to look like? Now, before you like, some of you in the next 1 or 2 minutes, you'll be like, aha, I see it, okay? But for the rest of you, let's try and process, because this is why this question comes at the end of the exam, okay? This is not a standard form, okay? Well, at least it's not an obvious standard form, okay? For instance, we can rule a few things out, right? What would you expect if the primitive were to be a log function? What format should you expect this to be in? Yeah?
The numerator should be the derivative of the denominator, or something that you can make into that.
So if you see f dash on f, okay, then you'll be like, okay, I know what to do with this, because when you integrate that, you're going to get log of whatever that function is. Okay, that's okay, all right? But you don't have that, and you don't have something close to that. What's the problem? Yeah, the degree just totally mismatches. So you've got degree 4 and degree 2 there, so you have to differentiate twice to get there, okay? Now, if it was degree 4 and degree 3, even if it was off by some kind of constant, that's fine. We can deal with constants. You can multiply and divide, and that's all right. But you can't just multiply by an x here and then divide by an x out there. We've seen how that just goes wrong, okay? So this is not what we have. What other kinds of options do we, present themselves to us? Yeah?
You could make it x on 1 plus x squared times x plus 1 x squared, and then work log function.
Okay, so you're suggesting this. I'm going to break it apart again. So.
Can you integrate quotient?
Well, okay, hold on. Let's just write down what you were saying. So you said x on 1 plus x squared times x on 1 plus x squared. That's what you're saying? Yeah. And that's f dash. Well, it's a sort of f dash on f. That's also sort of f dash on f, right? Is this okay?
What do?
It doesn't really help.
Hold on. I'm just trying to follow this logic, right? So I'm integrating a product of two f dashes on f's, okay? So are we suggesting that what this is going to be is log of one thing times log of another plus a constant? Does that work?
No.
Why not?
I don't know how to
Can we articulate why this is not true? Okay, why
because
not?
when you split up things that you're integrating, you can only split them up if they're plus and minus, not if they're time.
Okay, all right. So hold on a second. This line here, we broke apart the fraction, and that's fine. Okay. But this we broke up the fraction, and it busted. Why? Can we articulate this a little more clearer? Think back to when we first learned our rules for definite and indefinite integrals. Okay. What's this? This is a difference, right? Or if you think about it, it's a sum of a negative thing. Okay. The integral of where did I write it? Here. Integral of a sum is the same as the sum of the integrals, right? And you can think about that in terms of differentiation, right? If you differentiate x squared plus x, you can just take them separately, and that's all fine, right? But the derivative of a product, right, is not the product of the derivatives. It's not like, okay, 2x, okay, cos x, I'm done, right? It's not that simple, and that's why we learned the product rule, right? There is a whole such thing as the product rule, okay? So, unfortunately, this is also a bogus method, but it was worth a shot, right? You've got to try something, and we don't have any better answers yet, okay? Another suggestion. Any other suggestions?
Could you split up the top into, instead of splitting up the whole thing, you keep the denominator the same, and could you split up the top into 1 plus x squared, 1 minus x squared, and you cancel out?
Wait, where's the x squared?
Yeah.
Oh, 1 plus x, 1 minus x, sorry.
So,
but then that doesn't help either, never mind.
yeah, okay, so hold on, let's just stop for a second.
doesn't help.
What was he trying to do? I think what you were trying to do was rewrite the numerator in such a way so you can do some cancelling.
Yeah.
Is that right?
Yes,
Okay.
it did nothing.
But it didn't, what you suggested didn't quite work, okay? However, I think we're onto something here, okay? I think we do need to do some kind of rewriting of this numerator okay, in order to make it fit with the denominator. The real problem is that square, okay? Can you see how that's the problem, right? Because if the square wasn't there, I'd be able to deal with that, okay? I can break things apart in a sufficient way or factorize or whatever, okay? But with the square there, it's back to what Ivy said. The degree is the problem, and the 2 and the 4, I'm stuck, okay? So how can I write this in such a way that I can get rid of things? Yeah? Just pull out the everything squared.
Take out the squares on the top.
Okay, so you're suggesting write it as x on 1 plus x squared like that, and then let's say it's all squared.
That's the first thing we differentiate, but I don't know if that's relevant.
Now we ought to be suspicious, right? Because that is close, right?
It's the same as just.
But the only problem is this thing I differentiated, and I can differentiate. That's fine. But the problem I'm now presenting to it is integration. So it's a different problem. Now, if I were to try and integrate this, right? This is a function of a function. There's a function, and I'm squaring it. So function of a function. So in order to make that work, I need to have the derivative of the inside function there to make it be reverse chaining. Okay. So it also happens to be bogus. Where else could I go? Where else could I go?
When you phone a friend, putting on Mr. Woodhouse.
You don't need to phone a friend, okay?
Mr. Woodhouse.
Because I'm right here. I'm going to show you, okay? So before I reveal it to you, all right? This is my point. The reason why I'm trying to push you through this is because you will get to this point and you won't just magically have a teacher standing next to you saying, this is a good idea, okay? So you have to wrestle with, what do you do with this unfamiliar thing? Okay?
The characterization of a teacher.
So, alright, so here's the way I'm going to do it, okay? Now, think back to a question like, say, think of one. If I gave you something like, x plus 1 on, let's do this. If I gave you that, okay, what would you do? What would you do? Oh wait, sorry, hold on. I think I want it upside down. Do you want it upside down? Yes, I want it upside down. Sorry, try that again. That's what I meant to write. Okay, sorry, let's start again. What would you do to that? Now, I've deliberately given you one which you could factorize neatly, right? This is x plus 2, x plus 3, but that doesn't help you, does it? Right? What would you do instead?
Do you bring it up?
Bring what up?
What denominator up?
Where do I take it? What am I doing?
You're timesing it
What do you
by
mean by
nine.
bring it up?
Times it by the denominator in power of -1.
Yeah.
That doesn't really change.
Just split up the
Is there
top and
anything?
make them separate. No, it's so much easier.
Then multiply through.
Can you long division?
How do I multiply through?
It's the same function.
Mr. We use long division and then you end up with 2 different
Okay, all right. Now, so, this part of my point in illustrating this is you guys ate these questions for breakfast, right? You're like, I know what to do with these, but you did like a whole set of like 30 of them and you just got into the practice of it, okay? But now I give it to you without context and you're like, wait, what do we do again? It's not that hard. You divide, okay? So that's what Richard said, okay? So even though it factors into x plus 2, x plus 3, factoring into x plus 2 and x plus 3 doesn't help me because it doesn't get rid of the denominator, right? Can you see how this is similar to this problem now, right? So I need to put this into a form where it will divide through, okay? So how do I do that again? Just remind me. What am I actually going to do? Long division. So I'll go, why am I doing it this way? I'm going to do it this way, okay? -1, okay? 1, 5, 6, what do I do? How's your memory?
It's this weird thing.
You write the number down, 1. You multiply and then you multiply and then you add, you multiply and then you add. What does this mean?
And that is, the first one is the coefficient of the first
Yes.
thing, and then the last one's the remainder.
Okay, all right. So what was the point of this? Okay, now I can rewrite my numerator. This is x plus 4 times x plus 1. And what does this mean? It's just hanging off on the side.
2 over.
Okay, now what do I do?
Split it and divide.
Okay, now this I can split. I have a sum, right? You can break that apart, then you get some cancelling, and you're fine from there. Okay. All right, now let's have a look at this. Okay. Now you could sort of do something similar, right? But do you really need to? Do you really need to go to these lengths? How can you change the numerator in such a way that it will factorize and get rid of something on the denominator?
By adding.
Think about it. The denominator is already factorized.
You could add one as well.
Okay.
By
Okay.
adding minus
So
2.
I could add 1, but of course you can't just put numbers in because you want to. You've got to subtract 1 so that there's no net change. Okay. So this is fine. I haven't mucked around with this in any dramatic way. Now what?
Oh my god. Oh my god.
Okay, now, I'm going to let you settle on that. I'm going to come back to where I was writing this originally, okay? And I'll show you what's the quickest way to do this. Now that I know this is the kind of trick that I'm going to pull, okay? All right. So here, I want to turn this around. I actually don't want this to be a minus, okay? So I'm going to put a minus out there. I'm going to write this as x squared minus 1. Okay? The reason why is because I want this x squared and this x squared to talk to each other. So that's why I pull out the minus over here. Okay. All right, now, let's see what have I got here. Now I'll add my 1. Okay, so I've got 1 plus x squared. And that minus 1, like over there, right? It's actually up here, right? In order to compensate for the 1 I've just added, this should become minus 2. You okay with that? Like if I collected like terms, it'd go back to x squared minus 1. Okay? So that's all over 1 plus x squared with respect to x. Okay? So there's that 1 plus x squared that I'm after. And now I have a sum, or a difference, that I actually can break apart. Okay, see what's happening? All right, let me get rid of some space over here. Okay, what have I got? On the left-hand side, I actually have this evaluating thing. Okay, so square brackets. Sorry, x on 1 plus x squared, 0 to 1. Okay, let's start to break this thing apart. Okay, what have I got here? I'm going to have minus, and I'm going to write this as 2 integrals now. Okay, so I've got 1 plus x squared on 1 plus x squared squared with respect to x. Now that's a minus 2, and there's a minus sign out the front. Yeah, so that becomes plus, and I've got 2 over 1 plus x squared squared. Okay, are we okay? You tracking so far? Oh, sorry. Thank you. Okay, are we happy now? Yeah, looking all right? Now you can see where the thing that I'm actually working out has appeared. It's here, right? It's just that I've got 2 of them. Okay, so we'll get to him in a second. Let's leave him because I'm going to have another thing to evaluate between 0 and 1 in a second, so I might as well just lump them together. Okay, what's this going to be? When you do your cancelling, okay, you're going to get 0 to 1 of this. Now, what is that? This is tan inverse. This is why it appears in a 3 in an exam, not in a 2 in an exam. Okay, that's the sole reason. Okay. Then what do I have here? I've got double of the actual integral that I'm after. 0 to 1. Okay? So that was the hard part. Now I just need to do a little bit of rearranging. But you can see, all the work really, the hard thing to see was, this is where we got stuck. Right? We were trying to work out how we're going to get out of this denominator problem. Okay? And this was the way we did it. Okay, so don't forget, you don't just have the option of multiplying or dividing by constants to make things fit. You can also add and subtract things. Okay? All right, let's tidy up. Okay, this is what I'm after, so I'm going to make that the subject. 2 0 to 1 of 1 on squared. Sorry, it should be squared. Okay, now what's that equal to? This is, I'll open this guy up from 0 to 1, and him coming over, he's now added, right? So this is, like you told me, it's tan inverse from 0 to 1. Okay? Now I'm evaluating these two on the same boundaries, okay? So I can actually write that as one set of, well, one function, if you like, to evaluate, okay, from 0 to 1, because those two are equivalent. And what do I have here? I've got double what I actually want, so I might as well divide by 2 at the same time. Which means there's a half there. Okay. All right. Left-hand side's fine. That's actually what I was after. Right. So now I just finish off and let's tidy up. Okay. Let's evaluate it at 1, which is the upper bound. So what am I going to get? I'll get 1 on 1 plus 1. Plus tan inverse of 1, which is 4. There's my upper bound. Let's do the lower bound as well. I get 0 on, I don't care, okay? So 0, okay? Plus tan inverse of 0, which is 0. Okay, half times all that. And then you can go home. Okay? Well, actually not quite. I think this is actually not the actual last question. I think it's the second last question. So don't go home yet, but anyway, you get the idea. All right, so can we review, all right? It started off fairly gently, okay? And then you think, okay, I know I need to integrate both sides. And then when you need to rearrange, you have to be super careful, okay? One of the common things that people will do is they're like, oh, you know I need to factorize this out somehow, but that doesn't work. You quickly realize that you can't just do a pretty easy, straightforward thing. You have to do a weird thing, right? So some people, I kid you not, okay, because it's the end of the exam, running out of time, and you're panicking, you're thinking, I must have done something wrong. It has to factorize out somehow. That's probably not a minus. It's probably a plus. That works, and then you get 1 over, it cancels, and you're like, sweet, you're done, okay? And then you'll actually get it's not equal because you evaluate this, you evaluate that, and it's not true, okay? So pay careful attention to what you end up with here. And know that you've got plenty of tools in your toolbox for actually breaking apart integrals so you can put them into forms that you can work with. Okay?